Hello everyone, in this video we are going to simulate 4-bit subtractor in Multisim and also have the practical demo of 4-bit subtractor in breadboard using TTL IC. So let's start with the 4-bit subtractor and see how it works. So as you could see here, the 4-bit subtractor able to subtract one 4-bit numbers from the second 4-bit number. So as you could see here, A is the first input, B is the second input, and the unit's able to subtract A minus B and give the result in S. So as you know, whenever you subtract two 4 bits, so definitely the result just is 4-bit, but if B is greater than A, definitely should be the result should be negative. That's the reason you need another output to keep the sign for you. If this output is 0, it means the result is positive. If this is 1, result is negative. So here you see the summary of the whole things. A is 4-bit number, A0 to A3, B is 4-bit, B0 to P3. The unit's able to subtract these two numbers and give the result in SC to S3 and also keep in sign. So as I already mentioned in our previous video, so I really recommend before watching this video, watch two other recorded video. The first one is the 4-bit subtractor and how you could design the 4-bit subtractor using the 4-bit adder, and the second one is the subtraction with complement, which in that two videos I explain how you could use the 4-bit adders and able to add one combinational circuit and able to make one 4-bit subtraction using that 4-bit adder. So definitely I recommend watch that two video if really you want to understand how we could design this circuit. So as you could see here, we make the combinational circuit and one 4-bit adder and able to use just 4-bit adder and design a 4-bit subtractor. So as you could see here, this is your A, this is B, this is your S, and this is your sign. Which is the principle of this is what we explained in the beginning of in the first video for this course, which is was how you could do the subtraction with complement. So if you want to do A minus B, you could actually calculate A minus B with using A plus first complement of the B. So then check the carry. If carry is 1, you just add 1 to the lowest value bit. That will be the result of A minus B. If carry is 0, you just take the first complement of the result of the sum, or add the negative in the beginning of that. That's a result of A minus B. So again, I recommend watch subtraction with complement video and also 4-bit subtractor video. So in this video we are going to simulate this circuit, which is 4-bit subtractor, and we make that based of using the 4-bit adder. We simulate this circuit in the Multisim and make sure it works, and also we will implement this circuit in the breadboard using the TTL IC and see the circuit works or not. So let's start with the simulation. So let's first take a look to this. So this is exactly the same circuit that you saw in the OneNote. So this is 4-bit adder, same circuit that we have here. So we just implement this circuit in the simulation. For these 4A, we just we'll connect them to the switch, which able to give 0, 1. So the B same here, you need 4 switch, which gives 0, 1, and for the output, so you use the LED or indicator that you see what's the value of the output. Definitely you need 5, 1 for sign for the numbers. So which I did in the next simulation. This is exactly the previous circuit, just I add 4 switch connected with the A, 4 switch for B. And as you could see here, this switch is A4, this is A2, sorry, A4, 3, 2, 1. This one is B3, B4, B3, B2, and B1. So this is highest value, this is lowest value for A, this is highest value for B, this is lowest value for B. So let's start to simulation. Let's start with putting all to the zero. So let I actually put all the zero. So this switch that you see, one side of the switch connected to the 5 volt, which is 1. The next one is the ground for all of them. So that means whenever you open and close, so definitely you give 0, 1 to this specific bit that you have. So currently I put all of these switch on the 0 and simulate the circuit. So just make sure everything is 0. No, this one is not 0. So I put on the 0, 0. 0 minus 0 is 0. You see the result is the 0. And as already mentioned, whenever the result is 0, so the sign is don't care. So that means I don't care the sign is 0 or 1 or positive or negative, because whenever it is 0, definitely there is no sign for the 0. This circuit, whenever result is 0, give this 1, which is this is don't care, because we know whenever we have the 0 in the output, we don't care about the sign. So this is what we have. Whenever you have 0 minus 0, let's do check few other numbers. So I keep these B0 and give A the highest value, which is the 8. So right now I have A minus 0, so 8 minus 0 is 8. So these output, this is highest value, this is the lowest value. So that means right now I have 1, 0, 0, 0, which is 8. So which is right, 8 minus 0 is 8. Let's do change to this and change this one to 1. So right now I have 0, 1, 0, 0, which is 4. 4 minus 0 is 4. The sign is positive, which is right. So let's do change this. So I have 2 minus 0, result is 2. This is 0, which is positive, it's right. And finally check this. This is 1 minus 0, and this is 1, and the sign is positive. So let's do this time keep the A 0 and play with the B. So right now I'm putting these as a 8, 1, 0, 0, 0. So that means I have 0 minus 8, which should be negative 8. This is negative, and this is 8, which is right. So right now I give B 4, which is 0 minus 4 should be negative 4. It is right. So next 2, 0 minus 2 is negative 2. That's right. And the next is 1. 0 minus 1, you have negative 1, which is right. So you could actually test any numbers that you want. So let's do check few more. You have 8 here. Let I change here to 7. Okay. So 8 minus 7 is 1. That's right. Okay. So you could actually do more. So this is 8. Let's to add 12. So I have 12 here. And here, let's see what I have is 7. Okay, so 12 minus 7 should be positive 5, which is this is right. Okay, and you could test any numbers that you want. Let's test few negative numbers. So let's do A be 3, 0, 0, 1, 1 is 3. 3 minus probably let's do 4. Okay, this is 3. Let's keep these 4. So 3 minus 4 is negative 1. And let's check one more, which is keep these, I don't know, any number that you want. Probably this is 4. And let's do 8 here. Let's just put the 0, all 0. This should be 8. So I want to make 4 minus 8, which is negative 4. So as you can see, it works for any numbers that you actually give. And the circuit that we design is a 1 4-bit subtractor, which just we use the 1 4-bit adder to design that. So let's implement the same circuit with the TTL IC and take a look to the practical implement of the 4-bit subtractor using TTL ICs. So let's take a look to the practical implementation of the 4-bit subtractor. So here we implement the same circuit with the TTL IC. So we have the XOR, we have actually the NOT, and also 4-bit adder. So here we give A and B with the switch, and also the result in these output ports that we have. So right now, this one is, these first four is A, these four is B. This is A 4 3 2 1. This is B 4 3 2 1. So currently this is 0, this is 0, 0 minus 0 is 0. As you see in the simulation, whenever we have the 0 minus 0, which is give you a 0, usually the sign is on, which as I mentioned before, it is don't care, because whenever you have the 0, you don't care about the sign. So here this is the highest value bit in the output, S4, S3, S2, and S1. So let's start with the keep the B 0 and give the A 8. So as you see, 8 minus 0 is 8. So this is highest value, this is lowest value, and this is a sign. So sign is 0, so that means 8 minus 0 is positive 8. So let's check the next. Right now it is 4, 8, A is 4, B is 0. 4 minus 0 is 4. Positive is right. This is 2. Put 2 minus 0 is 2. And finally this is 1. 1 minus 0 again is positive 1. So the next test is similar what I did in simulation. I keep A, these 4, 0. This time I actually add the value to B. I add 8, 4, 2, 1. Definitely whenever it is 8, you have 0 minus A should be negative 8. That's right. So next I give B 4 and A still is 0. 0 minus 4 is negative 4. This is negative, this is 4. The next should be negative 2, and the next should be negative 1. So this is negative, this is 1. So you could try any actually numbers that you want. So let's try few more. So let I give here, give a 12, 8 plus 4, this is 12 for A. And for B, I give just 8. 12 minus 8 is 4, and the sign is positive. So let's back to the 0, try some negative numbers. So I give here 3 for the A, and for the B I give actually 4. So 3 minus 4 is negative 1, which is right. So you could actually try more negative numbers. To give this is 4, and for the next one to give this is 8. So should be 4 minus 8 should be negative 4. So as you could see, it works, and again you could try any numbers that you want. So let I just try one more and finish the test. So I give 8 for, which is 12, 14, 15, and test this one. So right now I have 15. I keep 15 here for A, and I give here 8. So see 8, 15 minus 8 is 7, right? So now I give 12. So you have 15 minus 12 is actually 3. So I give 1 more, which is 15 minus 14 is positive 1, and finally 15 minus 15 you have 0. So we don't care about sign because still you have a 0. So you could try for any numbers that you want and give A and B. Definitely the circuit should be work for any value that you are giving for A and B. So this is the practical implementation of 4-bit subtractor. I hope you like this video. Thank you for watching.